So welcome, ladies and germs. I'm going to give you a helpful hint for the Mba620 course, which is project 1, both section 2 and 3. We're going to go over some simplistic things that seem difficult and go over some other websites that actually give us some proper hints. So stay tuned and let's get to it. Go ahead and get ready and get started. So before we even start, I'm going to go ahead and pull this window over here and show you that this video that was posted by Professor Mr. Rambo, with this link at the top, use that as a guideline to actually graph the supply and demand in Excel. It shows you the basics and then it tells you how to change it. So right now we're going to go through it quickly. Good thing they have the thing called pause button, so you can go ahead and reverse and find out exactly how I did it. So we'll move that to the side here. So what we need to do is we need to first create a chart of some sort. So I'm going to go back and just select items that I had before. Yeah, and then go to Insert, Scatter with Lines. That produces that graph. We then right click on the graph, go to select data, delete both of these. So now we want to provide a new one for the demand quantity. So place your cursor in name and then click on that, and then the X values, which are the quantities, and then the Y value will be the price. Then we should see the graph in its proper form, which is a downslope for the price versus quantity. Now we go back and then right click on it again and select the data, and then we want to create another piece, which is the quantity of supply. So click in name, put your cursor in name, and then click on the cell 15C, which that now puts the name in there, and then X values, which are the 98 through 110, and then the Y values, which are the prices. Once you do that, and then hit OK, and you'll have your X, Y values for both supply and demand. And in this case, your equilibrium is $60. Per barrel at 102 barrels. So that's that graph. Whoops. So let's move that down. Y'all. So I hope that clarifies how that's done. The other thing was profit maximization, which was basically outlining how a gasoline station can maximize their profits for the amount of fuel that they spend on a daily basis. There was a fixed cost of $250 a day, and it was you basically have to go through here and find out what the median is to price and how much profit you can make by calculating supply and demand. So what we'll do is I'm going to use my sheet as an example. So this is my sheet for the supply and demand, so we'll go over to profit maximization. And this is one of your main values that you're going to use, which is the $2.04, 2.4049, which is the price that the gas station is being charged per gallon. It's basically the wholesale rate. Plus, you have a fixed cost of $250 per day, so that has to be calculated into it. So first question is, Cal sold 4,000 gallons per day at $2.189 per gallon. He raised the price of 1 cent to $2.199, and revenues and profits dropped. His station sold 3,600 gallons per day at $2.199 per gallon. Fixed costs were there. So that's outlined here. So this basically shows what he got for the 4,000 gallons, and this shows what he got for 3,600 gallons. Now what I did, and the feedback that I got from Professor Rambo was that, well, actually I didn't get anything back saying that this was supposed to be used, the last line. but I reused it anyway. So if you look here, this one was reused here, and then this second line was reused down here, and so it was a continuation of the calculations. So if we look at my calculations, so the first question was the quantity and the price. So I used formulas to outline, so if anything changed on the actual format of the document, all of the rest of the formulas would change, and you wouldn't have bad calculations if a single cell was changed. So if you look here, this was L37, which was L37. So that was the first cell that I'd use, and that's the calculation from it. And then the 218 was coming out of this one. So basically I just mimicked each one of the cells in a certain scenario, because if I change like this number to 2120, if you watch up here, it changed. So I tried to keep the format to where if there were subtle changes, it would fix all of the graphs and not just have a value with an exclamation mark stating that you messed something up. So let's go ahead and continue. 3,600 at $22.19. The average between the two numbers was 3,800 gallons, and the average price sold was $2.19. The change was 1.11% in the amount of fuel that was sold, and then the percentage change for the price was a little bit over 1%, and that calculates that gives you the calculation for the elasticity of demand. This is the calculation I use, which is basically these two numbers put together, and those are the calculations for the percentages. You have to make sure when you do these percentages that you go ahead and format the cells as well accordingly. You can change it to percentages. I changed it to 5 decimal points because there are instances in the actual worksheet where you need up to 5. So what I did is, this one says there was 4,000 gallons per day sold at $2.189. Total revenue for that amount of fuel sold was $8,756. The cost, the wholesale cost, which is here, that's where this number is coming from. So if you look up here, it's coming from Q13. That's cell Q13. Variable cost was $8,196, which is the cost per unit at times the volume. The fixed cost per day, which doesn't change at all, is $250. So I just went ahead and put $250 in this cell. Total cost, which is the fixed plus the variable, it's the variable cost plus the fixed cost. So these two put together. And if you look at the calculation, it shows you Q37 plus P37. So there's Q and P. And then it comes up with the overall revenue cost. And then what I did is, when we needed to calculate the other cells, you just drag it down. So there's formulas in these, and the formulas actually reflect what's gonna be the outcome. So all I just do is drag it down, and then the formula came down. For these ones, same thing. This is the same basic formula as we did in the first one. It's just different numbers. So all of the formulas that were performed up in here that are inside of the actual cells are the same ones down here. And that's the same for this one as well. No different. The number 4 is actually a breakdown of how much profit for the amount of fuel sold at the different prices. So the price is the biggest variable because that's going to drive your demand. So here was the demand, and then here are the different prices that were depicted. And basically it dropped down 1 cent per field, all the way down to $2.09. And then also your fixed cost. Your fixed cost is always going to be the same. The variable cost, all of these are calculations. The cost per gallon is fixed as well because it comes from, of course, the given values up here, the total cost per gallon. once that calculates out, and then basically these calculations are the same ones that are here, and it shows you all the different costs in the revenue. So you just basically look in through here and find out which cell has the most profit, which was 310, which was this one. I'm sorry, it was 326. So it was 4,800 gallons at $2.69 was the maximum profit. So number 5, once you calculate total profit, what was the profit maximizing price? So that's basically the answer that we found up here. And that was the answer. Caveat, please do not use my answers. Ha ha ha. Next calculation, marginal revenue, knowing that is the difference price between the revenue and the price shown, and the revenue at 1 to 400 of a cent less. Calculate 1 to 400 of a cent as well as the new price. So gallons sold per day, 400 to 1. So it was 3,600, 3,601, 4,000, 4,001, 4,400, 4,401, 4,800, 4,801, 5,200, 5,201. So it was 3,600, 4,000, 4,400, 4,800, 5,200. Those are the 400s. These are the ones right under them. And then the price for each one of those, you basically had to calculate out the percentage between the two, and then calculate this in from the percentage that came out of here with this one to get that number. Are you confused yet? Yes, I was. Anyways, marginal revenue, if you look it up inside of the work area, projects. So if we look in the great supply and demand graph, this will show, where is it? We're looking at elasticity. Yeah, here it is, elasticity of supply. You have to use this calculation to get those numbers that we got here. So marginal revenue, marginal cost. Does marginal cost and marginal revenue at the maximum profit? Does marginal cost equal marginal revenue at the maximum profit point? Well, here's your marginal cost and here's your marginal revenue. These are the two numbers that you look at. Do you get it? Anyways, this is not. So this does not equal. I'm not sure what else I can cover. Some of the questions was oil producing countries and US producing companies. The supply and demand graphs, you get this from I can't remember what it was called. It's up here. Yeah. So these are all the different questions, and the one that I got the actual information for the real world consumption stuff was here. Yeah. www.oilprice.com. Those you can actually export the graphs that they have on the website, which are these, which kind of makes it look pretty. So if you have any other questions, I can assist you, but I cannot give you answers. So anything else, let me know. Leave a comment below, since I am going to put this on YouTube this time. And if you have any other questions, you know what to do.